So as we go ahead and get started here, I just want to highlight that InMage was founded in 2002 by a gentleman with the name of Kumar Malavali, which is also the founder of Brocade Communications. We are a software company dedicated to data replication. That's all we do. There's no cloud services that we sell or any appliances. It's strictly focused on data movement from point A to point B. The product that we'll be talking about today is the Scout product. It's been in production since 2003. We are a USA-based company, but we do have offices worldwide. We have several patents around the technology that we're going to speak to today, as well as the market segment of CDP, or continuous data protection. It's heterogeneous from a storage or disaster recovery, and we're talking about business continuity from a disk backup to disk backup solution. We also have several partners that we work with, even at an OEM relationship level. So when we talk about disaster recovery, typically we think about the big natural disaster events that occur. The earthquake, the tornado, the hurricane, the different things like that. But in reality, what we're finding is that there's far more failures within the data center that we need to be concerned about. As you can see here on this highest one, the power failure is taking the majority of the disasters, if you will, or producing the most downtime within the environment. Followed up by hardware failure, network failure, and even winter storms and human errors in there before you hit kind of the majors that we think about from a disaster. So really what we want to understand is that a disaster is not always necessarily a big or a catastrophic event. A disaster could be simply losing a critical database, or it could be losing a critical file or group of files, or even a critical application within the data center. And that might only involve a single server. It doesn't even have to be an entire data center or an entire group of application servers. So what we're talking about with disaster recovery is just that. It's omitting ourselves from losing that data. One example that I like to point out is there's a customer who operates a 911 call center, and they leased 2 floors of a multi-story building, and there was a fire located on one of the other floors besides theirs, and they were forced to evacuate their building even though the fire was 3 floors above them from the fire marshal, and they did not have appropriate disaster recovery plans to handle their operations when the building was evacuated for several hours. And so that in and of itself becomes a disaster that we need to think about, and what InMage is going to help us replicate with. So why InMage? InMage is a unique value proposition. It's the only unified storage solution based on continuous data protection. It is at the block level. It is an asynchronous replication solution, so there is no distance limitations that you need to worry about. We are monitoring those changes as they occur passively, and we're sending that information to a remote location. So really we're focused on kind of 5 critical recovery challenges that we see in the marketplace. Whether it's disaster recovery, we have to talk about application availability and application consistency. Because after all, when you bring that application back online, is it in a state that's going to be ready to provide functionality to your users and to your customers? Meaning, can you process I/O transactions against that database or against that SharePoint or Exchange environment without having to do anything else but recover that data? And so bringing that application online in a consistent fashion is very important. Local backup as well as remote backup and recovery in a mixed environment, whether it's virtual or physical. We see a lot of mixed environments today with virtualization engines becoming very, very popular, and the ability to protect within those virtual environments, maintaining a very lightweight footprint and not adding any additional burden to any system within the environment. We also have built-in WAN optimization and SLA monitoring so that you will know exactly what's going on in your environment. You'll be able to provide reports of exactly what's happening. When you're talking about replication, it's important to understand what the recovery point objective and the recovery time objective is. We provide these reports for you on a real-time basis, giving you real-time RPO numbers on every logical volume that's being protected. We do have full enterprise scalability. We can work within Windows, Unix, Linux, any data applications, SaaS, cloud-enabled, it doesn't matter. From a replication standpoint, we're completely agnostic to the systems and the solutions that you have already deployed within your environment. From a performance basis, we're completely block level. We do have file level copy as well. It is a host offload solution. We're very, very sensitive to adding any load or overhead to production servers, and we keep that as minimal as possible. Additionally, we have the WAN optimization, and we support the 3 major virtualization vendors: VMware, Citrix Zen Server, and Microsoft Hyper-V. One of the unique features to the InMage technology is something we call sparse retention. And essentially what happens with sparse retention is we have the ability to recover data for very long periods of time still using block-level CDP. When you're doing block-level CDP, you have the capability to roll back your data down to the millisecond and present that data at any point in time in that millisecond. And you also know that we have those consistency points that we're taking at the application level. So what happens with traditional CDP is when you get a long-term retention, say a year or so, it uses a fair amount of storage in that retention volume, and so and it also takes a fair amount of time to present that data that might be a year old. Because what's happening is when you use CDP to present that data and you say, show me what that data looks like a year ago, it knows what the state of data is today, and it reads that transaction log in reverse and undoes essentially 1 year's worth of transactions before it can present that data to you. So undoing every millisecond of transactions for a year can take a fair bit of time before it can present your data. So what we've done is we've introduced sparse retention. And what sparse retention does is it allows us to retain fewer application consistency points as the data gets older. So represented on this graph here, the solid blue line would be a traditional CDP solution where you're maintaining every millisecond of change for that year. The red line is what sparse retention gives you the capability of doing. As sparse retention would be an example of, for the following week, you want to keep every single block of change that has occurred with a recovery point of every millisecond. And then you have essentially 4 tiers of customization that you can use. An example would be for the month following this week, you might only keep a daily consistency point of that application. And then for the remaining year, you might keep, a weekly or a monthly consistency point of that application. So ultimately what that allows us to do is it allows us to still provide long-term retention using CDP, and it still allows us to provide a very low RTO, that recovery time objective, meaning bringing your data back online in a usable state very, very quickly, by giving you the option of enabling this sparse retention capability. Also with InMage and InMage protection, there is no rehydration from deduplication. We do not deduplicate the information. We want to keep that recovery point and recovery time objective as close to 0 as possible. So we don't want you to get into a situation where you have to wait a period of time for your data to become undeduped or rehydrated before it's in a usable state. We also don't want anybody to get caught with not having enough available storage so that they can rehydrate that data and get into an operational or usable state. Because of our efficient use of the WAN connection, including compression and the WAN utilization utilities that we have, meaning we can set policies around date ranges, around time ranges. We can include and exclude specific servers, and we can also manage the bandwidth that's being replicated there, all within the product. You still get optimization at the WAN level. We do have application-specific protection, so we can recover many of the applications you find within the enterprise today, not the least of which Exchange, Microsoft SQL, Oracle SharePoint, some MySQL, BlackBerry Server, and many others are in there. The whole goal of this is to minimize that downtime and minimize that data loss, or that RPO and RTO. Again, that RPO is how much data are you willing to lose, or how far back in time do you have to go to recover good data. And that RTO is once you've discovered when that period of time is that you have good data, how quickly can you bring it online in a production state. We're going to bring both those as close to 0 as possible while still leveraging asynchronous replication solutions. We'll hop into a architecture diagram now. This is a high-level, just sample architecture that we typically see. There's several pieces to this that I'll build out. Essentially what we're looking at with the InMage solution is a host offload solution. There is a data tap or a piece of software that resides on the production servers. It's represented by the little blue guys on this screen here. That data tab simply passively monitors the write I/O. It does not interfere. It does not do any store and forward to the write I/O. You can think of that as a SCSI filter driver. Simply monitors the write change, and it hands that off down to a second tier of architecture, which is a process server. Again, InMage is a software-only company, so that process server is a dedicated machine, whether it's a physical piece of equipment or whether it's a virtual machine, it's up to you. But InMage will install the operating system and the binaries appropriate to manage the environment. By providing that host offload solution, we have the ability to provide some caching, queuing, compression, WAN acceleration, bandwidth management, the reporting, a web UI to manage the entire environment. Essentially, all command and control functions built within the product itself are done through these process servers. That's why we can leave those data tabs to be extremely lightweight. You're typically going to see about a 2% or less CPU overhead during a write transaction. If there are no write transactions, then the agent just sits dormant. If we build out the secondary site here is represented over a WAN connection. Again, it is an asynchronous replication solution, so distance is not an issue, whether it's the cabinet next door or whether you're replicating halfway around the world. The solution is still the same. Essentially what we have here is we build out the secondary site. We're simply representing that we can go from physical to virtual and physical to physical, as well as virtual to virtual and physical back to virtual. So any combination of P to V that you might have within your environment today is completely acceptable to be protected with InMage. In this representation here, we have 6 production physical servers replicating down into 5 virtual machines and replicating into a single physical server, showing a combination of that capability. In this scenario, we do have the data tabs that deploy on the target site. They are the same data tabs that are on the production side. They auto-train themselves whether they send or receive the data, and they simply receive that information at the block level, and they lay it down at the logical volumes that are associated to those servers on the target site. So what you're creating is a block-for-block identical copy at the logical volume level. You'll notice on the secondary site there's a control server and a fallback server. We do have the ability to distribute the process servers and control servers so that you have the web UI interface at the secondary site, and then the process server just simply does heavy lifting. As the environment scales out to hundreds or even thousands of machines, you can add multiple process servers as well. What this allows you to do is you have a single point of control at the control server on the secondary site that manages all of the information through any number of process servers you might have. In the event that you did experience a full site outage and the primary site were to become unavailable, you could still have the same interface that you're accustomed to at the secondary site. You simply log into the same interface with the same IP at that remote or secondary site, and you can manage your environment and recover that information. So from a recovery standpoint, you have the ability to present volumes at any point in time, and you can present those volumes virtually using 0 additional disk space. So you could literally see what a file system or a file structure looks like 2 days ago, 30 minutes ago, 10 minutes ago, 2 weeks ago, and you can present that data. Even if it's a 5 terabyte volume, you do not need 5 terabytes of additional disk space available. It will simply virtually present that volume. It will attach it to the operating system, and you'll simply be able to navigate that operating system as you would any other file that's attached there. This is something that we'll go through in the lab or the demo portion of today, and we'll recover some files. So you'll see that firsthand and how that's handled. Nonetheless, when we present that data, we have not broken replication in the background. So you can present that data as many times as you would like for recovery, and replication stays intact in the background. You can also present that data in read-write mode. So if it were SQL data or Oracle data, you can present it in read-write mode. You can actually run write transactions against that data. You can keep it up for a period of time for test dev or whatever it might be. And simply when you're done with that copy of data, you simply release that instance. It'll remove any of the write changes that you've done, and it'll simply unmount that representation of the data, and you just continue to go on your way because protection was still going in the background. We do also have full failover capability for applications that need push-button failover, where we can actually set up an application and we can create a job that's available to you. So in the event that you do need to fail over that application, you simply go into the web UI, simply select the run option, and it'll go through the failover process. And the failover process can include updating DNS and even Active Directory if you need to for that application. So some of the capabilities that we have by doing a host offload solution is the caching and queuing capability. Essentially what happens here is if the primary site were to lose communications with that secondary site for whatever reason, and it could not send that differential write changes, the process server will simply cache and queue that information on its local storage. So the production server doesn't know anything's wrong. It's going to continue to send that block level change information. The process server simply collects it on local storage. Once that target server becomes available, it'll communicate automatically back to the control server and process server. Say, differential changes down to that target machine. The benefit of that is you do not have to reestablish replication on a simple maintenance reboot or a small outage. The other benefit of that is you do not have a blackout window of when you cannot recover. So if we assume that we had an outage yesterday from, I don't know, 10 a.m. to 2 p.m., and we were able to cache those differential changes on the process server, we repaired the outage, and then overnight everything became differentially in sync again. And then today, you received a request to recover your data as it looked at noon yesterday, you would still have that capability to recover that data quickly and easily because of the caching queuing. As we build this slide out a little bit more, we see that we are hosting our one-to-many capabilities. It is a one-to-N solution as well as a many-to-one or an N-to-one solution. So here we're representing what it might look like in a tape backup environment, where we have multiple production servers being consolidated down to a single server down below that has the appropriate storage associated to it. Then you simply have a simplified backup agent there who hands it off to tape for the archive, long-term archive purposes. So if you have a requirement to maintain your data for 7, 9, 18, 21 years, based on what your industry is, you can still do that using the tape or archive medium. How this process would work is simply replicate those primary servers down to a single dedicated backup server, and you would simply present those volumes using the method we talked about, where you can present them at any point in time at a consistent state, and then those volumes would be handed off to your backup agent to be written to tape. And then you'd simply automatically unpresent those volumes and then move on to the next period of time you'd like to back up for. The next thing I'd like to talk about is the Scout vContinuum solution, specific to VMware and VMware virtualization. Because VMware has a lot of capabilities and APIs that we can tie into, and we are VMware partners, there are some capabilities that are very unique to the VMware environment that I'd like to highlight now. With the VMware solution, you'll notice that in the upper left-hand corner we have both physical and virtual machines that run in our vSphere environment. There is a vContinuum server, which is basically where the software runs that interacts with the APIs for VMware. Essentially what happens is when you select the server to protect, you'll simply go ahead and choose the ones that you want. You can select virtual to virtual, and you can also select a physical server. So in this example, we've selected one physical and 2 virtual servers here. How that's done is we simply query the vSphere environment, and it'll portray all of the servers that are available in that vSphere environment or that ESX server. And you simply choose to put a check mark next to the servers you'd like to protect. The next thing that happens is it takes a copy of the metadata off of those servers. If it's a physical server, it grabs the machine metadata. If it's a VMware, it grabs the VMX file, and it'll recreate those machines on the target vSphere environment. And it turns those machines off. They are not up and running. They're actually just created, and they don't have any storage associated to them. And the reason for that is because on those machines that you've selected to protect, all the storage volume are going to attach to the vContinuum target server, which is a guest machine that's up and running. Essentially, all of the system volumes, data volumes, log volumes, file volumes that are associated with the machines that you've just selected to protect will all be attached to the vContinuum target. And they will be receiving all the block level changes that we just spoke about. You'll have all the consistency points. You'll have all the capabilities that we just spoke about of physical servers available to you in virtual machines. We do not use the copy on write functionality or capability built into VMware. We are using the InMage technology for that very efficient 4K block write to keep that in sync. Essentially, once that's done, replication occurs. We'll grab those differential changes passively. We do not add any I/O overhead on the storage backplane. Everything's done in memory. And we send that information down to that vContinuum target, and this is your protected state. As that information changes, it's updated and replicated over to that vContinuum target. Again, you still have all the WAN capabilities and control capabilities. It's all managed through the user interface that we spoke about on the physical servers as well. When it comes time to do a recovery, you simply select the server that you want to recover. And again, the method you do this is you just query that vSphere environment, put a check mark next to the server that you would like to recover. The next thing you would do is you would actually tell it to roll back your storage either to the last known consistency state or some known consistency state within your retention period. You can also select a specific date and time down to the millisecond within that retention period. Once that time and date is selected, the master vContinuum target server will roll back that data to the appropriate time you've selected. It'll detach it from the Continuum target, and it'll attach it to the appropriate server that you're bringing online. At this point, you can also select any metadata changes that you might want, whether it's IP address, memory, CPU, display name, host name, different things like that can all be changed. And it'll automatically power on that virtual machine, and it'll apply any metadata changes that you may have requested during bringing that online. So at this point right now, by doing just a few simple mouse clicks, you've brought that server online in a production state. And if you selected a known consistency point, then that application that's running on that server is up and running and ready to go. This is another thing that we'll be showing in the demo today as well, is the process to bring that server online. So as we go through the demo next, we want to talk about our unified management interface for backup, recovery, replication, and failover. It's all the same interface that we'll be working with. There is for the vContinuum piece, there is another application that we work with as well as the unified interface to ensure that we get those API hooks in there. We'll show the simple RPO and RTO views. We can go down to the minutes, so we know exactly how far behind we are on any particular volume. It's a real-time number. We'll talk about that virtual machine failover as well as that item level recovery and virtual snapshot where we can present that data. At this time, I'm going to switch over to the lab environment. There is one question while I'm switching over here. The question was, is the app a server-centric or is it an application aware? So that's a great question. The data tab that we're talking about is not specific to an application. They are application aware, and they simply work if the application is recognized on the server where it's installed. It'll simply work to protect that. So the method in which we do that in a Microsoft world is we leverage the VSS or the volume shadow copy services. We don't deal with the shadow copy portion of VSS, but with the very first step of VSS is to create a consistent state of that VSS-aware application. And then InMage will insert a flag or a marker immediately after the last blocks of change that have occurred to create that consistent state. So essentially, all that information about changes being sent down as well as known points in time of when we can recover that data where it will be consistent. If it's not a VSS-aware application, we do work with the vendor-supplied methodology for consistency. So a good example of that would be Oracle. We use the RMAN functionality to create consistency within Oracle databases. Great question, thank you. As we connect into the lab here, this is the web interface that we're going to join into. We simply log in and authenticate into this environment here. And quickly what we see is a very high-level dashboard. In this dashboard, it shows us the plans that are being protected, and you can see very quickly that everything's happening. We've got green lights across the board. If there were any warnings or critical information, not only would it show up in the pie chart, but also over here on the right. And again, if there are any alerts or notifications, they would be available here for us as well. As we look at one of these plans, we're going to simply minimize the menu for a real estate perspective. What we see as we go in here is it tells us on this SQL 2008 server which volumes are being protected. This has one volume, the S volume. If there were multiple volumes, they would simply stack up below here, and you would see maybe a D for data, L for logs, or whatever it might be. Here it gives us the real-time RPO number. You can see that we have a very low RPO right now. And so what that's telling us is if there were an outage right now, we would lose well under a minute. We would lose less than well under a minute's worth of data. Just a few seconds of loss is what we would have. And it also tells us we're in differential sync, which means that we're just sending those differential write changes over. The other thing that we have is we have the policies specific to applications. So because it is recognized as a Microsoft SQL application, it builds a configuration change policy, which essentially monitors the metadata of that application, in this case Exchange, so that it can check for any changes, whether there's new tables added or new databases added. So that's something that you set to configure based on the timing that you need. In this lab, it's configured for every 12 hours. There's also readiness checks run on the primary and the secondary site. This is looking for any dependencies that SQL will need, and it's ensuring that those same dependencies are met on the secondary site. And if there were any failures, you would be notified here, and with a log link, so you could go in and see exactly what those failures might have been. Lastly, here we have the consistency policy. So this is the policy that you get to determine how often throughout the day you're going to take those consistency points. In this particular lab, it's set for every 15 minutes. You might become more aggressive or less aggressive based on what your needs are. But essentially what that's doing in this example with Microsoft SQL is it's working with the VSS service to create a consistent state of SQL. And it's not only replicating every millisecond of change, but it's also every 15 minutes flagging a known consistent state of that data. Down below, you can see our scenarios for recovery. We have a planned and an unplanned failover. We have a failback. We have a fast failback. There are other scenarios that can be built in here as well, such as DR testing and different things like that. These are simply the ones that you would select and choose run on if you were to initiate a full failover. As we go through the file presentation first, I'm simply going to minimize this screen here and bring up our RDP tool here. This happens to be our SQL server that has some files on it under the S volume. This is the one we just looked at that we're going to try to recover. Here's some data here, nothing fancy, just simple data here. We're going to create a disaster by deleting some of this data, and we're going to be able to recover it. So essentially I'm going to come in here and I'm just going to grab a handful of files here, and I will simply delete these files. And then, of course, we'll empty this recycle bin to ensure that they are deleted and we do have a disaster here. So I've just created a disaster by removing some files. This could be as simple as a disaster is. That could have been a database file if I went in and deleted the entire database file or database log, or maybe a mail store file off of a mail server. Nonetheless, what's happening is all of that change information I just did is being replicated over to the target machine. But because of our capability to roll back in time, I'm going to be able to recover this data very quickly, and I'm going to be able to recover it at a moment in time before we deleted it. So in order to do that, I'll simply go back into our interface. I'm going to select the Recovery tab because I do want to recover that data. I'm going to open up our menu on the side. And for this demo presentation, I'm going to use the Advanced menu so you can see exactly what's going on underneath the scenes here. So going into the Advanced menu, I want to create a recovery snapshot. The next thing I see is I'm going to see all the servers that are protected. Well, I know the name of the server that I want to recover, so I simply select that server, and then I choose the Recovery button down below. At this point, I'm given an option to use time-based recovery, or if there was an application on that volume that I wanted to recover, I could use application consistency. For demonstration purposes, I'll select this, and show you what happens next is I get a filter so that I can find the recovery tag that I might need. Then I'm also presented with several tags that I can just simply select any one of those, and I have several pages of tags to go back in time. So I know if I select any one of these, I'm going to a known consistent state, and that data, in this case the SQL data, would be completely accurate. I would not have to quiesce that data after it's recovered. Because we're doing simple files in this example, I do want to go to time-based. When I select time-based, it basically puts in the time of now. Everything is done in GMT time zone, so you don't have to do any time zone conversions if your target's in a different time zone. We also provide the data in local source time as well as GMT. So in this case here, we simply need to go back a few minutes. So I've got my hours, my minutes, my seconds, and my milliseconds. So I can simply take this and we'll roll it back, I don't know, just a few minutes. And I can even set a millisecond if I'd like to do that. The next option I have is, am I going to do a physical representation of this data or virtual? Because I do not have any additional drive space or white disk space on that server, I'm going to select virtual. And remember, virtual is to present that data using 0 additional disk space. It then asks me, do I need read-write capabilities? If it were an application, I would need those, and I'd simply provided a temporary location to put that information. Because it's a journal file system, I don't need them. I simply unselect them. The next thing it's going to ask me and present me with is the available drive letters on the target machine, because that's where I'm going to present this data is on the SQL target. I'll just simply select Z. If you would prefer to use a mount point, or if this was a Unix, Linux environment, you would simply state the mount point that you would like it to be presented to. Once I hit next, it gives me an overview of what it's going to do, tells me the server that it's going to present it on, which is a target server, tells me it's going to show me the S volume on the target server as the Z volume, and I'm going to use this point in time right here. And I'm using virtual disk. So once I confirm that that's indeed what I intended to do, I simply select Finish and let it go through the process. This time I'm going to open up our RDP session, and I'm going to go to the SQL target machine. I'm going to open it up, and you'll notice there is no Z drive here. There's simply the S volume. And while that process takes about 2 minutes in this lab to recover, I want to point out something on this S volume here as well. You'll notice the S volume on the target machine is unavailable to the operating system. We do this on purpose. We actually hide it even though it's connected to the kernel and receiving that change information. We don't want any accidental writes going to that S volume there. So it is hidden from the GUI of the operating system. You can see that our Z drive has appeared here automatically. It goes through the appropriate plug-and-play process to bring that online. And you can also see it thinks it's using just shy of 20 gigs to bring this information to us. At this point, we simply navigate into it. I'll pull it off to the side here a little bit so we can get some screen real estate. And you can see that we have all of our information here, including the files that we've deleted. I can even open these files and validate that indeed they are the files. If this were SQL data, I could launch SQL Enterprise Manager, Query Analyzer, and I could analyze this data. Because it's simple file servers and we want to recover them, we just need to copy them back into production. I'm going to cheat because we're in a lab, and I'm just going to have a UNC mount point already available here. I'm going to open up the location where we need to recover those files. Simply select the files that we need to recover and drag them back into production. I do want you to notice the date modified here on these files has not changed. Because we are doing block level CDP, that information stays the same. If you had any ACLs or security or anything like that, it would all be intact as well. At this time, everything is recovered. We can bring those files up and notice that we're in a good state and ready to go. That's as difficult as it becomes to recover files or test files with InMage protection. The next thing we can do is we can simply clean up that mount point by selecting it, releasing the drive, and confirming that we do in fact want to release that drive. Again, that'll take about a minute or two to go through the appropriate plug-and-play process in order to create that information. The next thing we want to do is we want to work with our VMware. You can see I have a protection job of VMware. If I select this, you can see I have several VM servers that are being protected in here with different things going on. And you can see we have real-time RPOs on each one of these servers or each one of these volumes that are being created here. So as we go through this process, I'm going to minimize this screen here. I'm going to connect into our source virtual machine server here through an RDP session. SQL is already up and running. We have an InMage database with a couple of tables here. I do have a quick sheeting file that I'll pull out here. It simply allows me to select some of these databases and show the content there. So simply select one of these databases just to show you it is an active SQL database. There's content in there. Nothing fancy, but there's content there. The next thing I want to do is I'm going to go ahead and minimize this RDP tab session. And I want to open up my vCenter. And I'm going to create a power failure on that server. So we were operating on this SQL 2008 virtual machine source. And I'm simply going to right-click. I'm going to choose power, and I'm going to create a power failure on that machine right now. Go ahead and open tasks down here. And you'll see that it is powered off. We have just experienced a disaster on that machine. It is no longer accessible. So in order to bring that online, we'll simply use the VMware interface that we have for the tie-ins to the API, called the vContinuum. What we do is we simply point it to our control and process servers, and we tell it to get the plans, and it'll query that control server and bring back any plans that are protected on VMware. Once it provides us with that information, we can then select to manage these plans, and we can tell it that we want to recover one of these servers. Well, we know that we want to recover the SQL, I almost selected the wrong one there, the SQL 2008 VMware source server. Tell this information about it. We have 2 disks being protected on it. Simply select Next. At this point, it's going to validate that information against the master target, and it's going to make sure that it is protected and that everything is available so it can bring it online. Once this is done, we'll have our recovery options that we can select, whether it's the latest tag or the latest consistency point, whether it's the latest time, or whether we want to specify a consistency point sometime within our retention window, or we want to specify a time within our retention window. So once this is done querying, it'll bring back that everything's okay, and I'm simply going to select, we'll choose the latest tag at this time, and then we'll be able to run through that process here. This query takes a few minutes, just depending upon what your environment looks like from a VMware perspective, what the CPU capabilities are, what the WAN bandwidth capabilities are to retrieve this information and present it here for us. So it typically takes about 1.5 minutes in this lab. And certainly it's done there. I'm going to select the latest tag, and I want it to run a readiness check for me, meaning is that latest tag, is it a validated tag, meaning can you guarantee that that data is going to be online and going to be in a clean and consistent state. So it'll run this readiness check for me for a couple minutes and validate that that tag is indeed a correct one. If there is an issue with that tag, it'll come back with information as well, and we can simply choose another point in time or a tag back in time. Again, if there's any questions along the way, feel free to use that chat function. I'll kind of keep an eye on that as we hit some low spots here. You can see that that tag has been verified and everything's happy. If it wasn't, we'd have corrective actions here. We simply give it a name. This is a cosmetic name. You can name it whatever you'd like. At this point, you have the opportunity to change the IP information if you'd like, CPU, memory information. I'm going to keep everything the same, so I simply select Next. At this point here, I've selected one server, but if I had selected multiple servers, maybe it was a multi-tier application with multiple servers that needed to come online, I could select all those servers together. They would all be listed here, and I could select the recovery order by editing this field here. At that instance, we have 2 methods of recovering. We have an FX or job-based recovery, which is used if there's multiple servers that needs an order of operations to be obeyed. If that's not the case, like it is here, and you just need the server to come online quickly, we can use the Windows WMI protocol to bring that server online very quickly, which is the option I'll select today. So I'm simply going to recover that. Pull this window to the side. What we're seeing happening now is, if you see in the background here, I've got our vCenter up and running. We want to kind of keep an eye on our SQL Server here as well, so that we can essentially see this turn on. And we'll also see some tasks running down here in the bottom. What's happening right now is that process of, on the vContinuum target server, it's recognizing which volumes that need to be associated to the SQL Server here. It's taking those volumes and rolling them back to the last known consistent state, so the application volume and the SQL volumes, any dependencies that it might have. So it's going to roll those volumes back to that known consistent state, or the point of time that you choose based on how you've done this. It's then going to hand those volumes, once they're rolled back to that point of consistency, it's going to hand them off to the virtual machine that's sitting there waiting for storage to be attached, and then it's going to start everything up and apply any changes that happen there. So we'll see here in another minute or so, we'll see some information happening down in the vCenter console where we see some storage changing around, and we'll ultimately see that virtual machine start up here very, very quickly. It takes about 2 minutes to go through that process. We do have some questions as we come through here. One question is do you need to use Mozilla or can I use IE? That's a great question. Yes, you can use Internet Explorer. That's not an issue at all. You can use Firefox, Internet Explorer, Safari, Opera, Chrome. We tried to keep the web interface very low key as far as we want you to be able to sit down at any machine in a disaster and be able to access the interface. We don't need you to find a specific browser or a specific version of a browser in order to use it. There are some Flash capabilities in that browser, but they're simply reporting capabilities. So core functionality can be used from anywhere. That's a great question. Thanks for that. And you'll notice there's some activity going on here. You'll notice that the SQL Server will be starting up here very shortly. And essentially we can connect into that and ensure that that's there. We do have one more question that has popped in. It says, do the InMage data tabs interfere with production I/O? The question to that is no, they don't. They're actually passive, and in fact, the data tabs run as services. You can go in and you can stop those services if you'd like, and because they do not have any store and forward capabilities, it does not interfere with the write path down to your production storage. Whether that production storage is direct attached within the server itself, whether it's SAN attached, iSCSI, it doesn't matter. It's completely agnostic to how that storage is attached. It's also agnostic to what the target looks like. You might have SAN attached in the production site. You might want iSCSI or direct attached in the remote or target location. That's completely fine as well. Thank you for that question. So it looks like our server here has started. Let me go ahead and see if we can bring up the console. And you can see Windows is starting up here now. And shortly we'll get the login. There it is now. Let me close our task just so we get a little more real estate here. And I'll go ahead and just log in right here on the console. Sending a Control-Alt-Delete. Simply logging into this machine here. Essentially the machine will come up. We'll get a recovery notification box here. So we simply can fill that out with any information you'd like there. And then now the key thing is we want to make sure SQL is up and running and SQL is running well. We just jump into our SQL Manager. And you'll notice that when we authenticate into SQL, we will not have any errors or anything. It's simply going to be happy and it'll accept our authentication. And we'll go in and we'll be able to query the information here locally. So we connected right in. No issues there. We'll expand these databases. You'll see that we have our InMage database, and we'll look at our tables here. And again, we have our contacts in a table called 1. Because we did a full server failover, my little sheet file is available to me as well, so I can simply go ahead and open that file. And we can run just a simple select query against that contact database, and you'll be able to see that everything is intact, and we were able to bring that server online. So you can see in just a couple of minutes, you're able to recover a full server and bring it online. This is now ready to accept production I/O. The only thing missing here is a network change to redirect DNS over this way. And again, that's an option that you guys can set in or you can manage manually there. So there we are with our query, and our application is up and running. It's up and running happily, and it took us just under a few minutes to bring that online. So that's the information I wanted to show in the demonstration today. Obviously, there's lots of capabilities built into the product, and we're not able to show them all in the time frame that we have today. At this time here, I would like to open the floor for the next few minutes to any questions that may come up. I'm happy to answer anything as they come, and again, if there's any follow-up questions that do not get addressed at this time, please reach out to sales@inmage.com, or you can see our 800 number there where you'll communicate with a backup specialist when you reach that number. So we had a question come in that says, do I have to use sparse retention on every server if it's available, or if it's enabled? The answer to that is no. Any retention policy that you set is actually very specific to just that server or even to that volume. And so if you select to use sparse retention on a specific server or a specific volume, you do not have to, or you're not required to use it across your entire environment. So it is very granular in the method in which you can roll that out. Thank you for that question. We have another question that says, is there a way to protect applications that are not DSS aware, such as Lotus Notes? The application is yes. The answer to that is yes. As you know, Lotus Notes or DB2, or there's several products out there that do not have consistency mechanisms built into them. In the case where we do that, we simply work with the file system itself, and we create a consistency point at that journal file system level. So if you're running that on Windows, we would create a BSS consistency point at the NTFS level. If you're running that within a Linux environment or Unix environment, we would work with that ext3 or 4 file system or whatever file system that's running on this journal to create those consistency points so that then you can recover that information. We have another question here that says, can you automate the failover process? And the answer is yes, we can automate that failover process. You can actually schedule it as well. And so if you wanted to bring that information online, say on a daily basis, maybe it's a report server and you want to bring it online on a daily basis, you can set that up to present that data on a daily basis at, I don't know, say 4 a.m., and then it's available all day long, and it simply automates that day after day to present that data at the last known consistency point time that you choose there. There's another question here that asks, do we differentiate from double take? Yes, we do quite a bit. With our host offload solution and the host offload capability we have, when we're talking about any agent-only based CDP or replication solution, by having that two-tier architecture, we offload all the heavy lifting onto that dedicated process server in this case. So it does all the caching, queuing, compression, encryption, all the overhead is done there. And what that allows us to is be very, very lightweight on your production server. That's not the case when you're dealing with any solution that's agent-based alone. They have to handle the caching, the queuing, any compression, or anything on your actual production server itself. And we've seen that CPU go, as high as 50, 60% on production servers. So there's quite a bit of difference there. We have a question here, is the solution available for other virtual environments as well? Absolutely it is. We did highlight the VMware capability simply because the APIs that VMware provide are very robust at this point in time. But we do have interactions and integrations with Citrix Zen Server as well as Microsoft Hyper-V, and those are constantly being improved as their API suites are improved as well. As it stands today, we certainly work with all the three majors, VMware, Citrix Zen Server, and Microsoft Hyper-V. And we can even work with some of the other ones that are out there as well, whether it be VirtualBox and different things like that. The integration will vary based on what the API set is available, but we certainly can work with and protect any server, whether it's virtual or physical. I'd really like to thank everybody for who has attended today. We'll end up just a few minutes early so you can get on to your next activities. I really appreciate your time. And again, if there's any follow-up questions, please reach out to us at sales@inmage.com or on the 800 number, and we'll happily follow up with you. Again, as a reminder, there will be some emails coming out after this presentation that contain the white papers and different things that were mentioned on the registration. So at this time, we'll end the WebEx. I'll stay online for a few minutes longer. If there's any questions that come in, I'll certainly answer those directly with you. But other than that, we're very appreciative of your time and have a wonderful day. Thank you.